right, everyone kind of gets settled. We are getting ourselves back on track because we've got lunch, and I'm really looking forward to this talk because, you know, bias is sometimes hard to identify, but in this talk, I'll just tell you what my bias is. I love Target, and I married a Target data science guy, so I can't wait to hear your talk. Thank you very much, Sravanthi. Let's go.
Thank you. So our unsung hero for today is the data platform, where your actual AI and trainings and all these models are going to be run in the data platforms. So I'm here today to share my experience about how to optimize the data platforms, storage, and compute, and much more beyond that. I know the pre-lunch sessions are going to be very difficult. Hunger is real. The same way, even in the data pipelines, it is hunger about storage, compute, and everything. So we need to tackle that. So a question to you. Raise your hand, how many of you received a page during the midnights saying that, hey, my pipeline is not running, or it was happened for the job is missing SLAs, and especially for the leaders. Right? See, we are seeing a couple of folks raising hands. But I'm sure in future, most of you guys are going to get the pages during the nights. The reason is you have to take these optimizations as a priority. If it is not, then that is where your job's running slow, your SLAs getting missed, and a lot of issues are going to happen. So that is where I'm here today to share about my experience on how we can optimize the data platforms. And quick introduction about myself. I am Sravanthi Kondoju. I'm a data platform lead at Target. I have over 17 years experience with all around data and infrastructures. And I'm passionate about infrastructures and enterprise data platforms. And I've been with Target from last 7 years. I enjoy Target too, working here. Yeah. So today's a quick agenda. A lot of people know about AI, models and all, but very less people are aware about what is the data platforms and all. So we will start with starting with understanding the data platforms. That is where the foundation of how the data platform looks and what actually runs in that particular data platforms. And then we talk about the scalability aspect of it. Gen AI, everybody is talking about Gen AI, and a lot of data is getting generated, and that is where the scalability comes into picture. So we need to talk about how to build these scalable infrastructures. And then we'll go ahead and talk about the optimization techniques which are related to the multiple layers. Like one is a storage layer, on top of that you have the computation layer, and beyond that we are also going to discuss about some of the operational optimizations as well. We talk about observability, we talk about the data governance and the lineage, a lot of other interesting things too. And then you will also walk away with the playbook for how you can optimize this if you wanted to implement these in your projects. That is where, followed by the question and answers. So to see this, understanding the data platforms, the underlying layer over here is the data infrastructures. So everybody getting confused a bit with the infrastructures and the platforms. Some people call that as vice versa. But the thing is, infrastructure is a layer where your actual hardware lies in. Your CPUs, your memories, and your firewalls, all these things will be in the infrastructure layer. On top of that, we have the data platforms. So within those data platforms, your actual pipelines will be running. So when you're talking to your data scientists, they talk about the data accuracy. They talk about the transformations. You need to transform your data. Even in the first talk, we were also discussing about, in the morning, she was explaining about you need to have the clean data. So otherwise you cannot have accuracy in the models. So where exactly these transformations and the business logic, all these things are happening here is, that is where our data pipelines, those are the three different layers what you have. Ingestion layer, data transformation layer, and then you have the consumption layer. So what exactly those layers are? You talk about the medallion architecture, you talk about the lakehouse architecture, or any of the things, these layers you must need to define for the logical separations. So the starting with the ingestion, what exactly that one is, you will identify your sources. Where I need to get this data? Do I need to get it from the traditional systems like Oracle or some kind of clickstream systems? For example, I log into the target.com as a user. You guys log in and search for some products. So all these clickstream related data is going and coming into the ingestion layer so that we can take a recommendation engine. The data scientist can run the recommendation engine on top of that, and we can even run the fraudulent activities, and a lot of things will be happening here. So for that, the first step is the ingestion of these data. And that is where we call it as a bronze layer of the things. And we also call it as a landing zone as well. And then that is where the next layer is the transformation layer. So you got these data in. You bring these data from all the sources to here. But you want to know whether it is accurate or whether it is bad data, missing records, null values, a lot of things, right? So how you are going to do that analysis and all these things is in the silver layer. So that is where your transformations are going to happen. So it depends on your size of the data. Few people will use the Python, right? Few people will use the Spark, especially your data size is growing. At Target, we have large amount of the petabytes of the data. So we go with the Spark computation engine. So for the PySpark and Scala Spark, use the Spark, and then if you go to this third layer, which is a gold layer of the things, that is where your dashboards are there. For example, your leaders want to see your dashboards, like a sales KPM. In the morning itself, that reports have to be ready for the C-level people to see, look at it, how the things are, the sales are and all. So that is where your gold layer comes into the picture. For example, like if you have GCP, then BigQuery, that is where your actual processed data, aggregated data will sit into the gold layer. And if it is a Hadoop systems, you have Hive. And the BI reporting tools, all like Tableau or QuickSight, whatever the BI reporting tools you have, that get connected to the gold layer so that you can see the business insights and all these things from this. And then, you know how the data platforms and pipelines looks like and why the scalable of the platforms are needed. Especially in the current situations, if we see a lot of new innovation. You can talk about the generative AI, you can talk about the new real-time use cases. If you see the last decade, a lot of companies used to have the batch data itself. We used to bring the data, and over the night the data has to be cleansed and transformed. Only in the morning the reports used to be ready. But right now, this is not a situation. These are all the real-time streaming use cases. Your data should come in right away. You have to transform it on the fly, and then you have to take a decision. Because if any of the credit card fraud is happening, you can't wait for tomorrow to wait until that, right? Same way, if you want to give some kind of a recommendation, you can't wait for that. So a lot of things in the real-time streaming is happening. So that is where you tend to see a large amount of the data getting generated. The current infrastructures, the current platforms are not sufficient. That is where we must need to have the scalable platforms. So now we know why the scalable platforms are needed and how to build them. To start with, first and foremost thing, we need to understand about the source systems. The source systems, it can be like a batch data, or it can be like a real-time streaming data, or you wanted to understand whether it is a third-party vendor data, where the data is coming from, and what formats of the data. Is it like a JSON files? Is it like a CSV files? Is it Parquet? There are different formats of the data. So you need to understand that formats first. And once you discover your source systems, and then you will be designing your architectural patterns. What are all the architectural patterns? So we used to see earlier with a medallion, that is where we saw the bronze, silver, gold, these type of the layers. But right now in the industry, even at Target, if you see, everybody is talking about the lakehouse architectures. So that is where all these new things like Hoodie and Iceberg and Delta, different file formats are coming into the place. So that is where you need to choose the architectural pattern based on, for example, your use cases are mostly on the streaming. Then you need to think about using Kappa architecture or Lambda architectures on the batch and streaming. So once you decide on the architectures, and the next is you need to scale it. For example, your traffic is huge and you have only the 2 lanes. What do you want to do? You want to add 2 more lanes additional, or you want to expand the existing 2 lanes itself? Width-wise, you want to increase so that more traffic can drive in. That is where this horizontal scalability and vertical scalability comes into the picture. In the vertical scalability, you will keep the same 2 lanes as it is, but you will be expanding the capacity. That means, like, if you take the CPU's perspective, CPUs and the RAM, you want to expand it. You want to vertically scale it. So within those 2 nodes itself, you are expanding your resources. But we prefer to go with the horizontal scalability. That is the important one, especially when you are dealing with a large amount of the petabytes of the systems to handle. So that is where, if you talk about the Hadoop systems, or if you talk about any of the cloud, so you will be adding up new nodes to the system instead of you are expanding the existing ones. So that kind of the scalability also you need to think. And then the last but not the least, it is a security and access management. You must need to take care about your PII, PCI, a lot of governance data, compliance data, regularity data, right? You need to do the encryptions, you need to do the data maskings and other things to take care about whether it is data is secure or not. So these are all the different things you need to think before building any of the data platforms. So now your data platforms are ready. So is it enough to just use that same data platforms as it is? Do you think so? No, it is not, because you must need to do the optimization. Optimization is the process. It is not, it's a continuous process. You need to do it the different layers. As a data platform person, we need to do the optimizations at the platforms. That means the storage, the compute, the operational things and all. And as a data engineers, the other people, like a data scientist, they will also do the optimizations at their end. For example, the runtime of the pipelines, how much time it is taking to run and all. So optimization is going to be the continuous efforts. And to start with, we'll talk about the storage first. So that is where the life cycle policies is the important one at the storage, because when you divide that, it can be on-prem clusters, it can be a cloud clusters, anything, storage tiering is a quite important one. Storage tiering is, you're dividing that into hot data, warm data, and then the cold data. So what exactly these data are? That means, for example, if I need a data on an everyday basis, so regularly I want to use that data, that is where the first storage tier, which is the hot data, belongs to. When it comes to the warm data, you have the data which is not being touched. Like I would say last 6 months you're not touching from the 90 days onwards. So that is going to be like a warm data. Cold data is nothing but you're not touching that data at all. It is just you're dumping this data, and only historical data, only yearly ones you want some reports, and you want to, otherwise you want to do comparison from this year with the last year, and all these kind of a rarely used data will be going into the cold data systems. And another important fact I would say from the Gartner, almost in 12 to 18 months, every organization is doubling the data. They are doubling that number. It's quite strange to see those bigger numbers. So what teams, the companies will do as organizations, they'll just tend to add more number of the nodes, more number of the storage, more number of the compute. But that is not going to be the solution. We should identify how much percentage of the data is in the cold, warm versus hot, so that you can set it up the life cycle policies. So that is where in the life cycle policies, you can automatically move this data. So after 90 days, I want to move it to the, I'm not touching that data. I want to move it to the, somewhere the warm data. Or 1 year, I don't even need that data at all. So I will set up a life cycle policies. You have admins, or then the platform team will set it up so that the data is moved to these different layers. What is the advantage? Cost. Everybody talks about the cost. If you go to the leadership level, to the even engineer, data scientist, everybody wants to reduce the cost. but you don't want to compromise at the performance wise. You want to still have the solid performance, but the cost you wanted to reduce it. So if you have these kind of the life cycle policies, that will help, because the storage cost is also going to be cheaper in the cold data systems, like it can be a glacier storage, or it can be some kind of a deep archival storage systems. And not only that, storage is one aspect of it, and other one is computations. While you are retrieving this particular data, it will reduce the scans. If you separate your data across your cold data, hot data, then for the hot data, you will be obviously reducing the scan because less amount of the data. In the organizations, only 30% is the hot data. So that is where you will be improving the performance as well while retrieving this data. And we talk about the lifecycle policies, and what are the other things which we have. Other things are like storage formats. Backbone of any of your data pipelines is a storage format. Because once you choose the storage format, if you want to change it later, it is going to be a much more painful, because whatever the tables you loaded, the data you dumped already, it is going to have a large amount of the time it takes to convert from one format to the other formats likewise. So that is where you would be choosing key decisions on some of the things based on like what type of the workloads I am running, whether I am running the batch data or I am running the real-time streaming data, or what kind of the operations I am doing. Am I doing any acids? That means any updates, any deletes. That is very important to choose what kind of the file formats you are using. And then the schema evolutions. That is where you wanted to know how frequently your data is changing, how you are modifying your columns, your source systems are deleting some columns, adding the columns. Your file format should be able to support these schema evolutions as well. So your performance is purely depends on what type of the file formats you are using. There is no right and wrong answers for what file formats you have. There are different file formats like ORC and Parquet. These two are like columnary file formats. And then if you see the other things like Avro, if you do a lot of schema changes, then you prefer the Avro for that. Then you have the latest ones like Hoodie and Delta, Iceberg. A lot of things you will hear more about these, because these are the file formats which support the ACID transactions. That is where you can do the updates, you can do the deletes. As people are coming from the OLTP system backgrounds, like in the Oracle, you can delete a record. You can update a record. But if you talk about the big data systems, these updates and deletes are much more tedious when you compare with the OLTP systems. That is where all these formattings like Delta formats, Iceberg, Hoodie came into the picture. Along with that, the other features like time travel. You wanted to go back to the previous version. Your data was deleted somehow. So you want to retrieve it back. So that is where you need to maintain the versions. All these versioning features, time travel features, everything comes default in the Delta. And even if you use the use cases, the Parquet and ORC we use for the batch analytics. So even within that also, based on what kind of the tools you are using. For example, if you are Hive queries, you are doing a lot of Hive queries, in that case you go ahead with the ORC. That is a file format which you use. And for all other additional analytics, Parquet, that works much better as well. And if you see, we are talking about the acids, the updates, deletes. That is where these Delta formats and lot of upserts and open file formats with Iceberg, and you need to decide among these based on whether yours is a read heavy, write heavy, what kind of the operations you are doing. Based on that, you need to choose these storage formats. And the other important thing is you hear a lot about other tools and technologies like Snowflake. You might have heard about it. How many of you are using Snowflake? A lot. So Snowflake that is where the decoupling of the storage and compute. So that is where you will be separating your storage and computational capacity. Along with that, like while you are choosing your storage, you can also think about what kind of a compressions I need, whether it is a snappy or zzip or lzo. Along with that, you also need to, the major problem is a small files problem. So that is where platform teams always thinks about these small file problems. Or as the data scientists, data engineers, everybody thinks about the size of the data, but sizing and the storage is cheaper, if you see. But that is where the small files comes with the computational issues. If you have large amount of the small files, your cluster will not perform as better as less small files. So that is where we have implemented the data platform at Target. We work closely with the data governance teams. We implemented this real-time use case to clean up the orphaned records. That means we identify the unused data sets, and we ran a lot of campaigns, we automated this process. What we have done for this as a first layer of the ingestion, we have taken the audit logs. So that audit logs has all the information about the ingestion patterns and which file has been touched when, by whom, and all these details. And then we transform the data. Second step is like where we filter this data, and we have done these cleansings, transformations and all. That is where the policy enforcement, we have done it with the governance teams. That means what data we can call it as, okay, I can delete it. There should be some timelines of that particular data. That is where these governance teams comes into the picture, and we partner with them and enforce those policies. And as an action, we have also started these campaigns as well, where we reached out to the teams and we automated, we logged those data sets, and to our surprise, there are large amount of the data sets which are not even being touched. Same like all other organizations, we dump all the data, and then we tend to use almost 50 to 60% of the data from that. So we still have a lot of amount of the data opportunities to do the cleanups. And then we also build the observability on top of that to build these dashboards on the file counts, what data is deleted and all. Along with that, the computational is the other aspects of this. In this computations that is where we created the node labels, what exactly that node labels are. For example, like we tend to see a lot of noisy neighbor problem. That means there is important jobs which need to be run on the same set of clusters, but there are bad jobs as well. There are a lot of rogue jobs, which we call it as. They don't intentionally run that, but when you are testing your some SQL queries or some other workloads or pipelines, that is where we tend to see these noisy neighbors. So that is where this node labels came into the picture. We separate the particular CPUs and the nodes especially. So we run those particular nodes. It will be like this. If you see the ETL loads in one of the set of the servers, and if you have the ad hoc means you're testing something. I don't want that to be disturbed into some other analytical queries or ETL queries. So that is where your node labels help in segregating these particular things, and this will be helpful. And along with that, you also need to choose the right set of the resources as well, whether you are running your auto scaling you want to enable based on your workloads, and what type of the instance. If you are using a cloud, whether you want to go with the memory intensive or CPU intensive, what kind of the workloads you are going. So you can choose that as well. Along with that, if you are choosing a Spark, there are specific settings in the computational side as well. You can use something like adaptive query execution or dynamic allocations. These are very specific to the Spark engine. Along with that, we also, at the computations, you also need to take care about the memory settings, because you tend to see a lot of GC issues as well in the platforms, where the data scientists, data engineers complain saying that, hey, my job is not running. Yesterday it was running fine, but today it is taking a lot of time. What is going to happen? We need to take a look at the GC tuning as well. Is there any of the GC pauses, and a lot of other things we need to take a look at that. And this is another example what we have implemented at Target, especially for the couple of important teams like a sales teams, where they are interfering, those jobs, queries are interfering with the other jobs. That is where the runtimes have been increased. We have set it up the different Hive server 2 pools. These are all the Hive queries. So we have created a separate Hive server 2 for the sales team, for the different teams we have. So especially for the important teams, we have segregated like that so that they don't interfere and they can run and submit the job successfully. And along with these storage and computational, other important thing is operational observability, operationalize optimizations. To start with the pipeline observability, that is where you need to track how much latency in the jobs and what is the throughput and how much error rates. These are the observability features which you need to implement in your pipelines. Along with that, you also need to implement your error handling features and retrials as well. It should not start from the start where you need not rerun the full job, especially when you're doing the data loads. It should start from where it has been stopped. So that is where these retrial things comes into the picture with the checkpointing and all. And other things is reliability and availability. So whenever we are setting up the data platforms, we'll ensure even one of the server goes down, and even one of the data center itself goes down. Still, it should be in an operational position where it should run your data pipelines and your models and everything. All your pipelines should be still running. So that is how you need to build your high availability of these platforms. The last but not least, the FinOps. That is where we even work with the showback teams to identify the costs on which teams are having a large amount of these storage cost and the computational costs and all. So we even tired that as a gold tier storage teams. So that means the top teams whose cost is more and whose storage is more, whose computational is more. And that is where we work through these showback reports, and the cost also will take into the consideration. This is the playbook for the final optimization. So if you want to implement your playbook in your pipelines, to start with, you first detect what kind of the query metrics, which queries are running slow, and what kind of the data which is not even been accessed from quite long. So that is where once you detect, and then you will analyze, you will identify like what are all the sizes, and then what are all the bad queries and all these things, and then you will act. The act means, if you go back to our previous slide of like partition strategies, like you can implement the partition strategies. You can move some of the data which is not touched into the cold storages as well, like archivals, and you can compact, and those are all the things you can do. And after that, you must need to validate. That is where you need to implement the benchmarking queries or benchmarking pipelines. So you will be running against what is my pipeline runtimes before and after, so that you will be having that kind of the benchmarking over here. And finally, once you do with all these, you must need to automate, because the manual things will take a lot of efforts, and it's a tedious process. So we need to automate. You need to schedule your jobs, and you need to set it up your add alerting and observability, all these things you need to implement your pipelines. So this is the playbook, and this is a few things which I wanted to share it with you, the open forum for questions right now. Any questions?
You kind of touched on this throughout a lot of your slides, where you need to understand how the business is going to use the data at the end to then make a bunch of the decisions that you talked about in storage and compute. And I think one of the challenges that we run into is separating what is considered an operational process from a reporting process that feels really close to operations but isn't. So how do you talk to your stakeholders or your business areas about some of the decisions they make when they think what they're doing, oh, that's an operation, I want it so perfect, but in actuality, it's probably closer to reporting or insight processes. So like real operations where you're paying somebody or someone's getting money back versus like insight reporting. Do you have any thoughts on how to work with stakeholders on that?
Yeah, so that's a good question. The first thing, whenever you're building the platforms or pipelines, you need to understand the downstream as well. So that is where you want to partition something, right? You wanted to partition on the columns. You wanted to set up some clustering keys and all. So once you understand the business, then only we will set it up like operational things on. Especially when it comes to this operational data, like it is a problem for every organization, I would say. Because even when we go back as a platform team, say, hey, can you delete that data? They'll say that, hey, I'm going to use that in the future. No one knows when that future comes. So that is where these kind of the things, like I showed you one of the use case what we implemented. We identify which data set, okay, this table is not being touched from a year. So this is not going to be in a hot storage. It needs to be moved into some kind of archival storage. Those kind of the life cycle policies you can automate, but how you can automate is you must need to have those kind of metrics with you. Which data sets and when it is being touched last and who are all the downstream users for that particular data sets. Once you have these things, then you can take a decision on top of that. It's going to be challenging, so that is where we work closely with the governance teams as well on top of that, platforms. Yeah.
That comment on like data storage versus compute, the snowflake example that you talked about. So I sit among a lot of conversations which is about different vendors and different this and different that, and egress cost comes up, you know, like the reason you should have your compute sitting next to your storage is because of egress cost. It takes a lot more to take it out. Any opinions to guide, like, you know, like what you think about it, you know, in terms of like, is it true that the compute needs to be next to the storage from a cost perspective?
Yeah, so let me pull up storage formats, data layout. That is very important, where exactly your storage is and your compute is. Let's assume your storage is sitting into one of the data center and your compute is somewhere far. So your nodes, because all these distributed systems is like a master and slave architecture, right? So it needs to interact, it needs to talk to each other. So that is where the data layout comes into the picture. And in the Snowflake, we don't use the Snowflake and it is going to be much more expensive. So we usually prefer to use things with the open source. But data layout and management is one of the important factor. That is where it decides like how much time it takes to go back and talk to the other data node. Because if you take Hadoop as an example, you have like 3 replicas. It sits into a different places. Whenever you require the compute, you need to talk to the storage. It needs to go and talk to that. So even the DNS things are also matters a lot. So we are working a lot on these networking things. Any of the packets are dropping. If any packets are dropping still, as end users, as a data engineers use these platforms, they'll come and say, hey, my pipelines are running slow. So as a platforms, it is our responsibility to check that any of the packets dropping, any of the DNS resolution taking time, and all these network related things comes into the picture. So that's why we recommend both of the things should be at the same place.
Hey, so I'm a data science student, and I'm not very I don't have a lot of experience with data analysis. I only more familiar with working on the school lab and stuff. I'm kind of concerned if I get a job or internship, and then let's say I fell behind with some of the steps. I know that every job is different, but is there any chances that I can communicate with coworkers or any sources that I can get help from to not fall behind with my data analysis process?
Sure. So the first and foremost thing is, for example, if you wanted to you want to learn more about the cloud, go to the cloud specific provider and take that, set up your one of the EC2 instance. If you talk about the AWS or GCP, they'll come up with these EMR clusters, for example. You can take that and you can do the practice, and it is free. You will get a lot of, until and unless you are running a lot of workloads there, then you need to pay. Otherwise, it is free. Always you need to make hands dirty by exploring those things. So I would recommend you to start with going to the cloud specific providers. And if you wanted to try with the Apache, so other things like if you wanted to run yourself and do something, then Apache has a very good documentations as well. So you can do some kind of the practice there too.
Thank you so much. Yeah.
What strategies do you use to protect sensitive data in data platforms?
Great question. sensitive data. So what we need to do is, there were some of the Apache we are talking about, like tools like Ranger policies, and if you set it up at the Ranger policies at the storage layer or a table level, so where we even have like a lot of different data encryptions as well. I don't want to talk about, name those encryptions and all what we use, but yes, we have the data encryptions at rest and data encryptions in motion as well. Along with that, if you are using the cloud, there are other things you can protect your sensitive data using the data maskings as well. If you're talking about the Snowflake, and there was dynamic data masking is there. So you can do the either row level policies, you can set it up the column level policies, using the Ranger is what we can do that. So that is one of the thing, which is free. It is open source. You need not pay anything. We encourage to use the open source. My personal opinion, not I'm not talking about my org.
Let's give a round of applause. What a really wonderful session.